Hello and welcome to the second day of our 2021 Eurocase conference, Engineering to Build Back Better. I'm Yasmin Ali and I will be your host for today. Yesterday we had two brilliant and stimulating sessions exploring the role of engineering in building a more sustainable and resilient future. Today we will focus on how we can make sure that that future works for absolutely everyone. We had great engagement from you yesterday. There will be further opportunities to share your thoughts on our topic today through our breakout discussion sessions later on. To kick off our first session this morning, I would like to introduce Dr. Hayatun Selim, who is the Chief Executive of the Royal Academy of Engineering.
Good morning, everyone. My name's Hayatun Selim and I'm the Chief Exec of the UK's Royal Academy of Engineering, and I'm delighted to welcome you virtually to the Royal Academy of Engineering for the second day of the 2021 Eurocase Summit. Thank you all for your excellent engagement yesterday and for joining us for today's discussions. And I would particularly like to send a warm greeting on this cold November day to our colleagues and friends from the Eurocase Academies. I hope that it won't be too long before I can welcome you in person to our home at Prince Philip House. The theme of today's conference is, of course, building back better after COVID-19. And building back better is a phrase that came into our lives early in the pandemic, encapsulating a shared aspiration to make sure that out of the tragic events that were then unfolding, something better could emerge. It felt fresh and hopeful a year ago, perhaps a little less so today. And that's partly because it's become a bit of a catch-all phrase, a slogan, to encompass a huge range of interventions and investments that will be needed to rebuild our economies and our societies following years of stagnation and, of course, the shock of the pandemic. But it's also partly because we haven't necessarily seen enough evidence that the warm words are being translated into meaningful action. But let's rewind and think back to this time last year to understand the almost radical nature of the phrase when it was first coined, and the license it gives us to reimagine our societies in a more resilient and more equitable world. COVID-19 has brought tragedy and disruption to so many lives, and nothing that we can say or do today will take away or to mitigate the suffering that has already been caused. But it's also true that the pandemic is a kind of stress test that our society receives once, maybe twice, hopefully not more, in a century. And we've learnt a lot from it. We've seen how quickly massive societal transformations can take place and how norms once challenged can be extremely difficult to reenact. There are lessons that we learnt from innovating in a crisis that give us a lot of hope about how we can achieve outcomes that we never dreamed would be possible in timescales that seem to defy gravity. And we can take forward that experience of radical innovation to help us to develop the technology and the systems that we need to decarbonise our societies, as we heard yesterday. Crucially, the pandemic also gives us a chance to change the way we think about equity and inclusivity. In the past, we've perhaps sometimes suffered from a perception that diversity and inclusion is a worthy but not business critical topic, and nice to have in a prosperous and healthy society, but probably not a priority in a crisis. The pandemic has turned that argument upside down. It's told us that it is in an emergency that we see in sharpest focus the critical importance of inclusion and diversity of thinking. And it's showed us that in some cases this can literally be a matter of life or death. Think of the higher death rates suffered by minority groups in many countries, or ventilators and other medical devices and interventions that were manufactured and produced at speed with the greatest of intentions, but proved unworkable. They didn't deliver the impact that was intended because they didn't adequately embed doctors' or patients' perspectives in their design. Even today, the myriad inequalities that have fed into the vaccine gap between the world's wealthiest and the world's poorest countries. And as today's news reminds us regarding the variant developing in Southern Africa, this ultimately impacts on all of us. It's helped crystallise something that engineering academies across Europe and across the world were already beginning to realise, which is that engineers' responsibilities for diversity and inclusion don't begin and end at improving access to the engineering profession for people from all backgrounds. This is very much necessary, but it is not sufficient. There is in fact a much larger piece of work that our engineering community needs to take on to ensure that the outcomes of all of our engineering endeavours are as inclusive as they can be and as they need to be. This is a major task for all of us to embrace. It requires rethinking many elements of engineering, from education and certification to design, decommissioning, supply chains, management of people, infrastructure, risk. But it's essential if engineers are to discharge their leadership responsibilities for addressing our global challenges and creating the sustainable, equitable and resilient society and economy that we all aspire to. So we hope today to begin to explore that new territory together and to hear voices from all over Europe who are grappling with this topic in myriad ways, to learn from the diversity of thought and experience across and beyond our brilliant Eurocase community. And together, we hope to take those first important steps in building back a better engineering profession, one with inclusion at the heart of everything that it does. Thank you so much.
Thank you so much for that. I think that's really set the scene for today. And I'd like to now introduce our keynote speaker for this morning. That is Professor Nebojša Nakicenovic. Professor Nakicenovic is Deputy Chair of the 7 Chief Scientific Advisors to the European Commission. Before this, he was the Deputy Director General and later Acting Director General of the International Institute for Applied Systems Analyses and Professor of Energy Economics at Vienna Technology University. So over to you, Professor Nakicenovic.
Good morning. I'm delighted that I have an opportunity to say a few words and would like to thank the organizers very much for the kind invitation. I would also like to apologize for not being able to be there with you in person. I find that the title of our session, Engineering an Inclusive Future, is really well chosen. And I see 2 different meanings, 2 related but different meanings. One is the contribution of the engineering communities toward inclusive future. And I would say, as I had been a professor of engineering until my retirement, and I know that my colleagues are engineers, are problem solvers, and we need that to achieve the inclusive future. But the other one is also the other meaning could be in the sense of creating an inclusive future, creating practical solutions of how to achieve an inclusive future. And I think that meaning is also very important. What you can see at the bottom of my title slide is 2 pictures of the recent report of the scientific advice mechanism of the European Commission on the systemic approach to the energy transition. On the left is the scientific opinion of the group of chief scientific advisors, and on the right is the evidence review report of SAPEA. I'll say a few more words about that later, but let me first just say that energy is one of the challenges facing the humanity in the future. As you can see here in this caricature, and I use a caricature on purpose to symbolize that we have immediate threats to humanity from the COVID-19 crisis, the climate crisis, the uncertain direction of the digital revolution, both bringing benefits and possible dangers, and also many people have been left behind. There is injustice, inequality, and at the same time, ever-increasing pressure on the Earth systems. So we have a confluence of crises and challenges and problems. So the world is facing problems, and yet I would argue that engineering, scientific, and medical communities have disciplines, and this needs to change, and I think is already changing. So let me start with the ever-increasing pressure on the Earth systems. As you can see here, I'm showing you the history of the climate of the planet during the period called the Holocene of the last 10,000 years on the horizontal scale against global mean temperature on the vertical scale. And the Holocene is characterized by quite a constant temperature over the last 9,000 or so years. And it was possible for for our ancestors to settle down, create early civilizations, and the agriculture, the so-called Neolithic Revolution. But you can see that in the recent years, there is a hockey stick. The temperature, the IPCC report, 6th assessment report of the Working Group 1, just reported that the global mean temperature increased by 1.1 degrees Celsius since the beginning of the Great Acceleration during the last half a century. On top of it, you see the Paris range of the temperature stabilization. This is important as the Conference of the Parties, the 26th Conference of the Parties, really finishes and reconfirms the need to have stabilization at 1.5 degrees. And you can see that's just an edge over where we are today. But even this Paris range that will be really challenging to achieve already poses great dangers. A number of tipping elements in the Earth systems are conceivable even in the current temperature range. The endangerment of the West Antarctic ice sheet on the left, Greenland ice, Arctic summer ice, alpine glaciers, and coral reefs are all threatened, and there are other potential tipping elements. So the point is that human existence on the planet Earth and our future is really important and depends in a fundamental way on the services of the Earth systems. And energy is a very big part of equation, both the generation of energy from the natural flows in the environment, but also the emissions of greenhouse gases due to energy services with fossil energy. And on the right, you see a number of pathways. The green one indicates that it is conceivable and still possible to achieve stabilization at 1.5 degrees, but it will require Herculean efforts in decarbonizing all of the human activities and, importantly, the energy system itself. And why is this important? I think this is really important. This map illustrates this, that there is a confluence of hazards. On top left, you can see the description. This is a confluence of drought intensity, water stress, heat waves, crop yield change, habitat degradation in the spatial distribution over the planet. And if you look at the Indian subcontinent, it is very red. That means that there the impacts and confluence of these hazards is exceedingly high. But Europe is also quite red. And I think what is really important in terms of achieving a safe future for everyone is that some of the tipping elements that I discussed at the beginning coincide actually with the areas like the monsoon, with the areas where you already have very high hazards from the future climate change and other global changes, and that will be affecting Europe as well. And this is why it's important to achieve a sustainable development of the energy system and a fundamental decarbonization of all of our activities. And this is, I think, the important role of the Sustainable Development Goals, the 17 goals of the 2030 Agenda of United Nations that has been adopted by all countries in the world in 2015, also along with the Paris Agreement a couple of months later. And the reason why I like this picture, it shows the 17 goals in a little bit unorderly fashion. In the foreground, you see goal 13, which is climate. Just behind it is goal 7, which is energy. And it's clearly that is very strongly linked together, also with education and so on. So all of the goals are linked, and they have 169 targets to be achieved. I think exceedingly important, but should be seen as a holistic agenda, as an agenda where we need to achieve synergies rather than blockages through the conflicts and the trade-offs. So it is an agenda about the people and the planet. And the European Green Deal that I'm sure most of you are familiar with is, in my view, a kind of an action agenda to realize the 17 SDGs. And I think fundamentally also simplifies the problem. And I think this is really important for tackling it in the practical sense. We have 8 priority areas. You can see that many of them are related to energy and climate, like on the left, supporting clean, affordable, and secure energy, or mobilizing industry for a clean and circular economy, or on the right, zero pollution ambitions for toxic-free environment, and so on. And also, very important, not to leave anybody behind in the bottom, to have a just transition, and securing the finance, which is exceedingly important in the energy area. So this is a very important agenda, in my view, and it has been further strengthened July this year by the Fit for 55 legislation that went into the power essentially at the same time as we published the 2 reports I showed at the beginning, the evidence review report of SAPEA and the scientific opinion of the group of chief scientific advisors. And again, here are the pictures of the 2 reports. You can download both of them from the website. Let me just say a few words about the scientific advice mechanism in the European Commission. Basically consists of these two groups, the chief scientific advisors and the SAPEA group, as well as the unit in the Commission. These are all 3 independent entities, but basically SAPEA produces an evidence review report. You can see that you can interpret that as an assessment of the energy transition, and that informs the scientific opinion that makes recommendations on the way forward. Let me also say that yesterday, my 2 colleagues, Peter Lund and Christoph Schmidt, who were the co-chairs of the evidence review report of SAPEA, reported only on that. So in the remaining minutes, I will focus a little bit on the recommendations of the scientific opinion, as I said, rooted in the evidence review report of the SAPEA. So we made first at the beginning 1 broad recommendation, and that is that European energy policy should be designed in such a way to be clearly aimed towards achieving climate neutrality and sustainability, and importantly, not to leave anybody behind in the sense of the European Green Deal. On the right, you can see under the Fit for 55 package, how the European greenhouse gas emission would look like, 55% reduction by 2030, and essentially a climate neutrality by 2050. There will be some remaining emissions in the sectors that are very difficult to decarbonize and would be offset by net negative emissions. I hope that most of those would be nature-based solutions such as afforestation and sustainable agriculture, but there might be also carbon capture and storage as a part of the equation. But what is important is that all of the sectors need to contract basically at the same time. And to achieve that, we need a holistic and systemic approach to maximize the synergies and avoid trade-offs and barriers across technologies, regulatory and market measures, and social and behavioral changes. And I would like to stress social and behavioral changes. We need to put people at the center. Otherwise, this Herculean effort of achieving climate by neutrality in 2050 and starting with the process immediately would be threatened in the long run. And I think this is really deeply rooted in the science, confirmed by the IPCC's 1.5 special report, and now by the 6th assessment report. This is based on an article we published in Science in 2017 that shows basically the challenge. The gray area are the emissions from the carbon emissions from the energy systems and the land use, about 40 billion tons per year. And I call that carbon law, or some of us call this carbon law, because it means that in order to achieve Paris Agreement, we have to essentially halve the emissions every decade. That's the nature of the law. There would be some positive emissions left by the middle of the century. But not only that, we will need to enhance the carbon sinks, as I mentioned below, that's orange and yellow area. And very importantly, the third effort is to make sure that natural sinks are not weakened. As I mentioned before, we are threatening through the tipping elements and other extreme events the functioning of the Earth systems that actually remove half of the carbon that we emit into the atmosphere. So it's a threefold challenge and needs to be achieved. And this is why the Fit for 55 is such an important package that is perfectly consistent what the evidence review report of SAPER and our scientific opinion on the way forward recommend that needs to be done. And here is from the IPCC special report. You can see essentially the same need to halve the emissions every decade through a number of measures requiring a very steep decline, peak in 2020 that has already passed behind, and the emissions are still increasing, indicating how difficult the problem is. And it will require many measures, also described in the SAPER report, in our evidence, also in our scientific opinion, full power sector decarbonization, very important that you see it toward the bottom, electrification of all of the uses, and really improvement of energy efficiency at all levels. And now there are a number of technologies that would have to be directed in this area. And for example, freight transportation, aviation might be very difficult. And this is probably where we will also need green hydrogen, perhaps at the beginning, blue hydrogen, but that's the required way forward. Now we make three specific recommendations for the energy transition. First one is to develop flexible, efficient, and resilient European energy systems for delivering clean, accessible, and affordable energy services by integrating decarbonized energy sources, electrification, and the use, as I mentioned, of hydrogen. Second, really important, recognize the role of all of the actors and stakeholders in creating an inclusive and participatory environment that incentivizes and supports low carbon energy choices. And the third recommendation is to support a coordinated combination of policies, measures, and instruments, including carbon pricing as a driving force to shape an effective and consistent just regulatory system. And you can imagine that this is a really big challenge on the way forward. In particular, over the last few months, we have seen an explosive increase in the energy prices across the world. We need to react to that. We issued a statement on that point that what will be required is an immediate support of households at risk of energy poverty, along with the investments to increase the share of carbon energy production in the system. So the price of carbon, if it's implemented through tradable permits or taxes or both, will create revenue. That revenue should go to protect those that are at the risk of the energy poverty, and also to incentivize the investments and innovation. That would make the energy production more affordable and more reliable, but that requires upfront investments. It's not automatic, and also phase out of coal and other fossils. So Europe must commit clearly to accepting high carbon prices, but at the same time protecting people in danger of energy poverty, at least at the interim, until cheaper energy sources like the renewables and energy services diffuse to be pervasive. And last but not least, society, we need society's approval for and support of the clean energy transition, and that will require active engagement with the public and all of the actors to support low carbon choices. In fact, making low carbon choices the preferred choice. And for that, we need to foster technological innovation and change. So I'm coming to the conclusion of my very brief comments, and would like to end on a positive note. What you see here are 5 areas of human activities that engineering communities have enabled on top of the railways. Then you see flying machines, then telecommunication systems, individual mobility, and industrial processes. And please note how fundamental the changes were at the periods of about 50 years. And what is important, also we had the vertical, is that the systems merge together. None of us know how 2050 with zero emissions might look like, but would be technologies like this. And I think this is an important, enormous future contribution of the engineering communities, also at the institutional side, to develop and diffuse and make affordable the technologies for the better life of all and for making peace with the nature. Thank you very much.
Thank you so much for that, Naki. That was a great way to kick off the session today, and it's good to see that finish on a positive note. That did really pick up on the theme of sustainability that we discussed quite a bit yesterday, and started that discussion around the focus of today, which is the social implications of this topic. Unfortunately, we don't have time for Q&A with our speakers today, but instead we will have breakout sessions following our presentations, where there will be lots of time to reflect on and discuss what we've heard. So please do hold on to your comments and questions and bring those with you to the breakout sessions. We've got 3 short presentations now. Our first speaker is Dr. Nuria Oliver, who has over 25 years of research experience working on human-centered AI. She is co-founder of ELIS, that stands for the European Laboratory for Learning and Intelligent Systems, chief data scientist at DataPop Alliance, and chief scientific advisor to the Vodafone Institute. Nuria.
Hello, I'm Nuria Oliver. I'm a member of the Spanish Royal Academy of Engineering and co-founder and director of the ELIS in Alicante Foundation. And today I'm going to share with you my view on what we will need to do to leverage artificial intelligence in a sustainable way. But first, let's think about some of the challenges that we face as a species, starting with the aging of the population, where in many regions in the world, particularly Western Europe and Japan, what used to be an aging pyramid, it is increasingly becoming an inverted pyramid, leading to significant challenges from a variety of perspectives: demographics, healthcare, social, labor, and so forth. We also live in a planet that has limited resources, and if we continue consuming at the rate that we are consuming, soon we will need 2 planets Earth, which we don't have. Moreover, these resources are not evenly allocated. In fact, in the 21st century, we are witnessing a polarization in the accumulation of wealth, such that the 100 richest people in the world own more than the 4 billion poorest people in the world. And of course, we lived in a world with a climate emergency, where the average temperatures on the planet are rising, and in consequence also the levels of our oceans and seas are also rising, and the intensity and frequency of natural disasters is also increasing. And as we all have experienced in our own lives since March of 2020, we live in a world susceptible to global pandemics. My first message today is that we won't be able to tackle any of these challenges without the help of artificial intelligence. Because let's also not forget about the context. From a technological perspective, we live in really exciting times that are captured with the term of the 4th Industrial Revolution, a revolution that is profoundly transforming society as we know it, in the same way as previous industrial revolutions. The 4th Industrial Revolution represents a very intimate relationship between the physical, the digital, and the biological worlds, and it is enabled by disciplines such as biotechnology, nanotechnology, genetic engineering, and of course, artificial intelligence. Artificial intelligence is the discipline that exists since the 1950s within computer science or engineering, whose objective is the creation of computationally intelligent systems taking as a reference human intelligence. And as I said before, we need artificial intelligence to tackle today's most pressing challenges. But we do need a socially sustainable artificial intelligence, something that we don't have today. And in this AI-driven world, where are we, the women? Do we actually have gender equality in artificial intelligence? And unfortunately, the answer is no. AI lacks diversity today, at least in 3 ways. First of all, in the discipline itself, with a majority of men creating, designing, implementing, and deploying the systems that are used pretty much everywhere on the planet. Instead of increasing, the numbers of women have been actually declining over the years. Secondly, we have a lack of diversity in the AI algorithms themselves. leading to what is called the filter bubble and echo chambers. And finally, we also have a lack of diversity in the type of organizations that are leading and defining the future of the research, the innovation, and the deployment of AI in the world. Let's look at each of these factors in a little bit more detail. Let's start with the discipline. So where are we, the women in AI? So I guess we are in this picture. I challenge you to find the lady in the picture. Unfortunately, the vast majority of researchers and practitioners in AI today are men. We do know that as a consequence of the fourth industrial revolution, there will be a lot of new jobs that will appear, and most of those jobs will be in the technological field. Only in Europe, it is expected that there will be hundreds of thousands of new technology-based jobs that we don't have the talent to actually fill, and even much less the feminine talent to fill them in, leading to actually a loss in innovation of billions of euros annually only in Europe. When we look at the evolution of the percentage of women in different disciplines, this is data for the US over time, we find that for all the degrees, the number of women has been increasing over time, except for the degree marked in gray, which is actually computer science, where since the 1980s, the percentage of women has been decreasing. If we look at the different students registered per field, and this is data for Spain, again, we find that in computer science, the percentage of women is around 12%. When we look at the number of women that actually hold technical positions in technology companies, again, we find that the percentages are really low and women are a minority. But more importantly, there is also a very large percentage of attrition of women who work in the technology sector, women that actually overcome all the barriers to be able to join the sector and however decide to abandon it because of its culture. And when we look at the innovation side of things and startups, we find that 70% of startups do not have any woman in their board of directors, and more than half do not have any woman in executive leadership positions. In fact, less than 3% of VC-funded companies are led by women, even though many studies show that women-led startups outperform men-led startups. And why is this? So there is a variety of reasons why, but particularly I wanted to highlight 4 sets of reasons. First of all, due to stereotypes about who works in technology, what the profession is about, what computer science, how computer science and engineering is taught, and also what society expects from boys versus girls. The second set of factors are due to what is called gender biases, which make all of us, men and women, systematically undervalue women. And this gender bias leads to fewer girls than boys opting to study careers that seem to be difficult, such as engineering or computer science, even if they have better grades than the boys in their class. There is also a systematic lack of recognition and visibility of women overall, and particularly in technology and in AI. There is a gender gap, which in the technology sector is around 14%, but there is also a huge lack of recognition. When we look at the percentage of women that are given awards versus men, we find that they are disproportionately underrepresented. And finally, as I alluded, there is also a challenge related to the culture that there is in many technology sectors or companies. Is a culture called the programmer culture, which is extremely misogynist and sexist, and is actually causing many women to leave their positions to change career paths and join other sectors. But secondly, artificial intelligence also lacks diversity in the algorithms themselves, leading to what is called algorithmic discrimination and bias, where the algorithms can replicate underlying patterns of discrimination existing in society or even exacerbate them. There have been many, many examples of algorithmic discrimination in commercial products. For example, how face detection and recognition systems recognize light-skinned men with almost perfect accuracy, but they have much poor performance with dark-skinned women. Or biases found in algorithms to determine healthcare for patients or to determine the credit limits in their financial products. And of course, we are also subject to race and gender stereotypes on a day-to-day basis. For example, when we search on the web, if I search for chief executive officer person, I find pictures of a middle-aged man. But if I search for house cleaner, I find pictures and icons of women. If you are interested on this topic, there are several non-experts or books for non-experts that present many examples of these kinds of algorithmic discriminations. And in fact, on December 13th, I'm co-organizer of a workshop at NeurIPS called Human-Centered AI, where one of the topics that we will talk about is actually algorithmic discrimination. So we have a lack of diversity in the discipline, a lack of diversity in the algorithms, and we also have a lack of diversity in the type of organizations that are leading AI, where not only in terms of the deployment of AI, but also in terms of the research in AI, the leadership right now is not in what we would expect the best academic institutions in the world, but in some of the best technology companies. For example, when we look at the number of scientific publications in NeurIPS of 2019, which was the last time NeurIPS was in person, the institution with the most publications is Google, with more than twice the number of publications, and the second institution, which would be MIT. When we look at innovation and we look at the companies with the most AI patents, again, the leadership is with mainly American or Asian companies. And that's why, being European, we decided to create, the scientific community in Europe decided to create ELIS, meaning the European Laboratory for Learning and Intelligent Systems, as a way to try to contribute to Europe's technological sovereignty in AI. One of the actions that ELIS has launched is the creation of ELIS units. And one of the 34 ELIS units is the ELIS unit in Alicante, Spain, that I created, called the Institute of Humanity-Centric AI. And it's one of the very few research institutions that is devoted exclusively to research on artificial intelligence from a human-centric perspective, to make sure that artificial intelligence will actually have positive impact in our society. Thank you very much.
Thank you so much for that, Nuria. I think that was a very clearly described issue that you set out for us there, and a good example of what can be done about it. And maybe this is an opportunity to do something about this issue before it gets too far. The book that was mentioned, Weapons of Math Destruction, that came up yesterday as well. So Anne-Marie and Elena, two of our speakers, mentioned it. So I think I will be trying to find that book after this conference. Our next speaker for today is Professor John Hassler, Professor of Economics at the Institute for International Economic Studies at Stockholm University. He is a member of the Royal Swedish Academy of Sciences and the Royal Swedish Academy of Engineering Sciences, and has previously served as the chairman of the Swedish Fiscal Policy Council. Over to you, John.
Thank you very much. I'm a macroeconomist, but over the last 10 years, my research focus has been on climate change, and in particular climate policy. And in doing that, I've had the opportunity to work with people, researchers from other areas, in particular in the engineering sciences, but also natural science. And that has been very rewarding, and it also makes me particularly pleased to speak at the EuroCase annual conference. So I'm going to speak about climate change, and I suppose that I'll start with a picture of the state Earth is in that I think you might recognize. And one of the points in this picture is that we are overusing the world's ecological resources big time. We are threatening the survival of mankind by having an acute climate crisis. We are close to tipping points that will change the climate abruptly and turn climate change into something that we cannot control anymore, making climate policy too late. To make things worse, we often also hear that solutions are extremely costly and require a complete change of lifestyle, negative growth, and at least in the developed world, unseen structural change, and a new economic and perhaps also political system. So I think that you recognize this picture, but I will challenge it. I think that this picture is not really correct, and I don't think that spreading it is conducive to solving the many problems that we are facing. With this picture rather points a very bleak future for Earth. And I think instead that one needs to go into the details of the problems and in perhaps an engineering way, without losing the big picture, also see that the problems can be solved by a detailed inspection of everything that needs to be changed. So let me start with an example of this misinterpretation of what we see in data. So you've already heard that some data argue that we are overusing the ecological resources of Earth, and it's often said that we are using 1.7 Earths in terms of the ecological capacity, and this data comes from a serious organization of researchers called the Global Footprint Network. And you see here that we have actually since the late 60s overused our ecological resources. And this, of course, paints a very bleak picture, but I think one needs to go behind the data here and look in more detail on what is happening. So what's behind the curve? Well, you can see that there are 6 categories here. And they are land, built up land, cropland, fishing grounds, forest products, and grazing land. And they altogether are 5 of these 6 factors that make up the use of ecological capacity. And these 5 altogether have grown since the 60s, but not massively quickly. Considering that GDP has increased by a factor 7 or so since over this time, and population has increased by 150%, one might think that the increase here is not very large, although of course it cannot continue. So what's the remaining 6th factor that needs to be added in order to come up to 1.7? Well, that's actually carbon. So here the data that gives this high use of ecological resources is computed by calculating how much forest would need to be planted in order to absorb the CO2 that we now emit. And you can see that that's much too much. We cannot solve the problem in this way. So let me now turn to what we need to do. We of course need to get climate neutral. And what science says about this is that climate change is proportional to historically accumulated emissions, and the 6th IPCC report gives us a number for that. And this implies that it gets worse the longer we wait, but it's not becoming too late for policy. And IPCC clearly states that we are not close to global tipping points that could cause uncontrollable climate change. There are local and very problematic irreversibilities and perhaps also tipping elements, but it's not that we are soon going to pass a threshold making climate policy too late. So what policy is required? Well, we need something that is not in principle complicated, and policy needs to fix the fundamental problem of climate change, and that is that the atmosphere's capacity to absorb CO2 is a natural resource in limited supply that has been and still largely is free to use in unlimited quantities. And this produces what we often call a tragedy of the commons. And the solution is simply, in terms of policy, to establish property rights to this natural resource, a tradable emission allowance system, putting a price on this resource that needs to be priced. And what we find in our economic research is that even a modest emission price is quite effective. A price as low as $20 per ton, corresponding to about 5 cents per liter of gasoline that grows with GDP, has large effects. We need global participation in pricing. If China does not participate, we're going to require 20 times higher prices in the rest of the world, and that's not possible. It's not really important to have an emission price that is equal everywhere in the world, but all regions must at least have some price. And the first step here is the most important. And what we also can show, both in our research and others, is that in combination with green investment support and redistribution, a transition to climate neutrality in 2050 can take place globally without negative consequences for growth and equality. But without pricing, it doesn't work. So we show that transition to climate neutrality by 2050 is a good insurance policy. We cannot prove that it's necessary. There is too much uncertainty about the consequences of emitting CO2 to say that. But certainly we can say that this is a good insurance policy in the terms that it costs little and has very high potential value, and that's we should do. The EU Commission now proposes a faster phase-out of allocation of new emission rights and to set up a new emission trading system for transport and heating. This is going to give full control over almost all future emissions in the Union. And we can also calculate how much that's going to contribute to final global warming from emissions in the EU. And we can find that that's in the order of 0.02 degrees, and that's something that we should be proud of. And this is going to imply that firms that cannot find emission-free alternatives will simply go out of business. But thanks to in particular the engineering community, I'm sure that emission-free alternatives will be found. This proposal implies that focus in terms of policy now can be on making the transition smooth so that the system does not lose its political and popular support. National policies as well as company policies focusing on emission levels become obsolete. And I think that we now have on the table a proposal that really deals with the climate problem, and it shows to the rest of the world that also a quite heterogeneous area like the European Union can agree on the required policy for the transition to climate neutrality. And that makes me much more optimistic than what the initial picture would make me be. So there are reasons to be optimistic. Thank you very much.
Thank you so much, John. Again, it's good to see the optimism there. You picked up on carbon pricing. That was a topic from yesterday as well, which seems simple, but really highlights the complexity of the world that we live in. So it would be good to see maybe people discussing that in the breakout sessions later. We've got one more speaker before those breakout sessions. That is Professor Nick Pidgeon. Nick is Professor of Environmental Psychology and Risk at Cardiff University and Director of the Understanding Risk Research Group. His interdisciplinary research portfolio looks at public engagement, communication and decision-making for the environment, low carbon energy and emerging technology risks. So over to you, Nick.
Good morning. Good morning, and thank you, Jasmine, and thank you very much to the organisers for the invitation to come and talk with you today. In fact, I started work a number of years ago working with engineers looking at the human components of major engineering disasters, because you learn in engineering through things that go wrong, unfortunately, sometimes, but then after time worked more on public engagement with climate change and the energy transition question. And that's what I'll be talking about today. Next slide. Thank you. So here, really, we have to take a step back. It's easy to think about the energy transition as a technological and scientific challenge, and it clearly is, and there are major challenges in there. But really, it's only there because it's a human and social problem. The drivers of anthropogenic climate change are the things we do. So the food the heating of our homes and buildings, transportation, our consumption of products, and also overlying this population growth is another of the drivers of climate change. Solutions currently are talked really in terms of three interlinked domains: new technology, engineering interventions, of course the main topic of this conference, economic instruments, as we've just seen, will be very important. And then there's an emerging debate about how much can lifestyle change contribute to this issue. Change will need to be systemic and embedded within societies, and I'll come back to that. And an important point, change is unlikely to succeed if we don't get a social license for change. What we in our research group call a social contract for change. So the public and citizens have to come along with that change. Otherwise it will, it or parts of it will fail. Next slide. So thinking about this, we know a lot about public engagement with and attitudes towards individual components of the energy system, actually. So views on flying, views on insulating your home, views on transport, nuclear energy, renewable energy, have been studied in some depth over the time. But the issue we now face is that all of this has to change together. It's a systems problem, and bits of the system interact with other bits of the system. So how can we have that conversation and engage with the public in a just and fair way about that change as a whole? Next slide. Thank you. The SAPIA report is important, but you have to remember also that as territorial or country-based level, there will be particular challenges. On the left-hand side, that's a project we're currently running on trying to understand delivering net zero for the UK and what the challenges are there. There are some interesting background documents people can go to. And then on the right-hand side, you can see this is the UK's Climate Change Committee balanced net zero pathway, and you'll see a number of wedges and other things that have to be worked on. The top two actually are very people focused: reduced demand and improved energy efficiency. There's a debate as to how big that reduced demand can be. Some people would argue it should be larger. And then a range of technological options from low carbon electricity through to carbon capture and storage. And then the final green bar at the bottom of as we have heard, is predominantly land use change to sequester carbon at a national level in order to offset some of the emissions that will be very difficult to decarbonise. And there are people challenges in all of these, both through acceptance of efficiency measures, through to acceptance of new technology and siting for large-scale energy production or hydrogen production, and on to the greenhouse gas removal. Next slide. Thank you. And people are implicated here. We're all energy producers and consumers, so we have a role there. We're citizens with voting powers, so we have the power actually to stop a process or support a process through the ballot box. And then, of course, as we've seen over the years, and certainly recently with the climate protests we've had across Europe, active proponents and protesters around particular issues and elements of the energy transition. Next slide. Thank you. Now, how do we engage the public about the enormity of the system change problem? Now, that is a real issue that researchers have just started to work on over the last 10 years. We did a first major exercise for the UK Energy Research Centre just over 10 years ago. You can see there the report and a paper and a range of papers from that project. And what we did, and actually the Academy was involved quite early on, and that bottom publication on public engagement in 2014 looking at the public role in engaging the public with the energy system change. So that's an important report to look at as well. We use something which is still available, and those of you who are watching this after the today, do go away and have a play with this, because it's absolutely fascinating. David Mackay, the Mackay calculator is named after, was the former chief scientist at the Department of Energy here and climate change. He was a physicist and engineer as well. And he wanted a tool that could engage members of the public and be used for planning to look at the different aspects of the energy transition. So what you can do with the calculator, you see on the right-hand side, the bar at the top right-hand side is your carbon, current carbon achievement by 2050, and then by changing the levers at the bottom across both the supply and the demand side, and also greenhouse gas removal, you can make your choices about what aspects of the energy system you want to change. And it's quite hard actually to reach the net zero target, and also there are interesting interactions built into the tool. So if you just produce lots of new hydrogen, currently it's not produced in a green way. So you also have to have lots of carbon capture and storage in order to produce what's called blue hydrogen in the first instance. So we used that with members of the public, an earlier version, in workshops for about a day, and got them to debate and discuss their different choices in order to try to see if they could reach the carbon target. And it was a very successful piece of work we did. Next slide, please. Since that, there have been a number of really interesting developments in Europe, which have got citizens to do a similar sort of exercise, by which I mean take the elements of the energy system change problem, and then over a period of sessions in an assembly or a jury type process, try to debate the aspects of that they feel are important for their particular country. The first one actually was the Citizen Assembly in Ireland. You can see there at the top, there's a lot of information on the web about that. And then we've had a very large Climate Assembly UK, with again a very large report that was published about a year ago. Again, it took very much took this systems-based approach to engaging with members of the public who took part in this. These were all a random allocation of citizens who took part over a period of time. One of the main recommendations of the citizens in those assemblies was that the energy transition should be just and fair. I think for the breakout groups, if we can go on to my final slide, this is the set of issues that we need to discuss. Next slide, please. Thank you. So what does a just energy transition really mean? And I would urge you to have a discussion about this in your breakout groups, because it's a fascinating subject. Philosophers and others have looked at it, and you'll see on the top there are three different really faces of a just transition for the energy system. Slightly wordy, there's what's called procedural justice, distributional and recognition. And to explain the three of those, procedural justice is the process of change fair? So have we included all the people we needed to include? Did we include them early enough in the process? So radioactive waste siting, which we know is a thorny problem still in many countries across Europe, has benefited in one or two countries, particularly Sweden and Finland, from very long and large-scale engagement with publics who might host those facilities, and that has led to some movement on that siting process. Distributional justice, are the risks and benefits evenly spread? So if we, for example, if one industry in the fossil fuel industry closes at a particular region that loses economic activity there, because we're trying to benefit the country as a whole or Europe as a whole by removing carbon emissions, then what are the co-benefits that can be put back to that community which compensate for that loss? And then recognition justice is rather interesting, something that's not often thought about in engineering terms. People have identities, values, local interests that really need to be respected in this whole process. So that says there's a very geographic aspect to the energy transition as well. Four critical challenges before I finish. Transforming older industries and economic activity. How do we do that in a fair way? broadly, how do we change the existing fossil fuel industry that doesn't impact those unfairly who are working in it? We've already heard we need to guard against the unanticipated impacts of new systems upon people who are energy poor or vulnerable to that. There's a question about ensuring resilience for all in the face of climate impacts. And then finally, something that the Royal Academy in their nanotechnologies report almost 20 years ago started to talk about: how do we ensure our innovation is responsible in relation to societal goals? That's my final slide. Thank you. And thank you very much for listening this morning.
Thank you so much for that, Nick. We did talk about systems yesterday, but not when it comes to engaging people. So it's really interesting to hear that perspective. And I'll just throw in another book as well, since David Mackay's been mentioned. I would recommend Climate Change Without the Hot Air, which I believe you can download for free online. And that's a good read as well. So we've heard a broad ranging set of perspectives on the theme today, considering how we can build inclusion into our engineering and policy making. I've definitely started to think about how I can build that into my own job as an engineer, and I hope that you have as well, and that you've heard something that's challenged you. We now have the opportunity to explore these themes further, thinking through what they might mean for our national and sectoral context as we look to build a more inclusive future. We're going to move into breakout sessions shortly, where you'll have the chance to meet and discuss what we've heard with other attendees from across Europe. We've got about 50 minutes for the discussion, so do make the most of the time to reflect on the themes that we've discussed over the last 2 days and what they mean for you, your organisation or your sector. You might have already seen the discussion questions for these sessions. They are available under the programme tab on the platform. Don't worry, we're not going to leave you completely by yourself. Each group will have a chair and also a member of Academy staff who will guide the discussion and help with any further questions or any technical issues if you have them. So to join the breakout sessions, scroll down below the main live stream that you can see right now and below the Q&A area, and click on the button indicated to join the breakout discussions. Do leave this live stream open on your browser. After the discussion, we'll return to this main session here where we will have a sum up and close of the event. So I'll leave you to it now, and I hope that you enjoy the breakout sessions.